Hey, welcome to How To in a Few. This is a series of boat maintenance repair videos that all kind of stem from a single issue. The issue is that I lost some power. The motor wasn't quite running right. Originally I thought it was a carburetor issue, and I managed to get it idling really good and running pretty good in the driveway, but then when I take it in the water, I continue to have problems with it, not having power, missing, shaking, etc. So in the meantime, we diagnosed it to the stator, and that video is coming. That's going to be a very good video, so make sure you subscribe so you don't miss that one. But during the course of getting to the stator, which is on the top of the engine, actually you can see the new stator here, already installed. We have to take off the flywheel, and there's a series of magnets underneath, and when I inspected those, several were cracked and dislodged, and although they can be re-epoxied and glued back to the flywheel, we went ahead and located a remanufactured one, which is on its way here. So as soon as we get that, we'll be able to go. But the reason why I'm telling you all this, so these engines have an issue with having a little bit too much heat up here, which causes the stator to melt, actually have a meltdown, and start to leak. It has this kind of gooey, oily substance in it, and that leaks and interferes with a timing. There's also a timing device underneath the stator. Long story short, I recently changed the water pump just as general maintenance, and I decided I'm going to go ahead and open these thermostat covers and change the thermostats. I don't really suspect that the engine's running or overheating per se, but it might be running a little bit on the hot side, maybe not enough to trip any alarms, but since we're doing all this, it's one more thing to do, so I ordered the thermostats. Now I didn't take them out, so I had no idea, but they are super small, 20 bucks a piece. One just arrived through one carrier, and the other one is supposed to be on the way and delivered today too. So I have one in my possession, so I decided I'm going to go ahead and start dismantling and seeing what it looks like. I kind of anticipate there to be a little crud in there. I'm going to open up both ports, and then there's also a block port right here. I don't know yet. I may open that just out of curiosity to look in there, flush it out with a hose. We'll see. But first things first, I'm going to move some of the electrical wires out of the way, and I guess we'll start on this one and open this up and take a look inside. Alright, most of the time I don't like to make more work for myself, but this time I probably will. $20 for thermostat and no included gasket. A little hesitant to try to force these hoses off. Let's just see what happens. like I'm going to take both sides off so that I can remove this whole assembly and not crack or pinch this hose. All the screws almost appear to be the same, although, oh, the washers are all stuck on there. Alright, so here's our whole assembly. This is looking awfully crusty. Whoop. See if we, whatever this is, I'm gonna check that out and do a little cleaning job on that component. And actually, this all looks pretty clean. Cleaner than I anticipated. Even the gaskets are pretty much pristine. There we go. They just pop off. Alright, here's our little other piece. Looks to be a screen. Some kind. Alright, I'm losing washers. Alright. So this was a stopper. Like a one-way valve or something? Pretty interesting. Alright, hopefully we can get that back in. Alright, we're back. And just to recap, we did some cleaning around these surfaces, cleaning of the parts, which I'll show you in a minute. This surface looks really good. We're going to reuse the gaskets. But although I'm not a fan of using an RTV chemical gasket product most of the time, due to the fact that there's a lot of corrosion here, that kind of tells me that there was a little leakage there, so I kind of want to prevent that. And then on this thermostat housing over here, we also had some corrosion here, and it actually kind of scarred the gasket a little bit, so I am gonna cover that surface with a little RTV before we put it all back together. Now let's take a look at the parts that we have. All right, our two new thermostats are right here, front and center. I cleaned off these O-rings real good. Cleaned off these gaskets for the housing. Also cleaned off each of these, and this is like a bypass valve where the seal is going to be reinserted when we go to install it. But I will RTV these surfaces, just the mating surface to the block, not the mating surface of the gasket to the plastic backing. that's really about it. So I'm gonna start putting it back together. Alright, first thing I'm gonna do is stick our thermostat with the rubber seal on the bottom into the opening where it belongs. There'll be a spring that'll hold it in place. And we're going to go ahead and rub a little RTV, and it's not going to be much. Not going to be much, because remember, all I'm trying to do is prevent that salt water from migrating around and causing corrosion. I don't want the sealant oozing out of the side like you see on some people's engines. Alright, I've just reinserted the seal here that we cleaned, and this is like a bypass valve. Also going to place this seal back. There are some holders. Now you can't see it, but there's little protrusions that are made to hold the gasket in place. And it should be clear that this is not the correct way. So let's flip it. Now, that side's ready. Like this might need to be on top. Alright, now this is a plastic cover, so we are going to only tighten them down, you know, with that in mind, that we're tightening down onto plastic. All right, everything's good. I didn't like the crusty nature of this connector earlier, so I'm gonna get some dielectric grease and just kind of check out those connectors real quick before I put them back in a permanent position. So dielectric grease is usually a non-conductive silicone-based grease, which you can use on electrical connectors, kind of make them waterproof. Because the grease won't conduct. Usually pretty good about these connectors. Actually surprised about how dirty they are. I'll tell you, zip ties must have been invented for boats. I've never seen an industry rely so much on zip ties. believe it or not, other than the application of a little corrosion protection back on these screws and covers, yes, I'm a paintaholic, but when you're dealing with a saltwater environment, which can be relentless, you have to take every possible precaution. Alright, so believe it or not, that's it. 2 new thermostats, kind of an interesting design. It looks as if they're more of a bypass type situation, where when there's enough pressure, the water actually bypasses the thermostat, flows down through the block attachment. Look, I didn't engineer the engine, it's just different than what I've seen in other motors. It looks like the thermostat only opens in a situation where the motor is idling, but I could be wrong. In any event, brand new thermostats. We cleaned up and kind of reconditioned the gaskets to reuse those both on the thermostat and the housing, and kind of cleaned up a little bypass valve there. And that, I mean, unless it was a defective thermostat, that component is for sure, those components are for sure working as should be. So we actually got the new flywheel for the stator with the magnets while we're working on this, but I'm dripping in sweat, and we're going to save that for tomorrow or maybe another day. And otherwise I'd start it up and we'd see, well, we wouldn't see really much except for some water coming out of the pee hole. But there it is, 2 new thermostats, getting the cooling system back in shape. Hopefully that helped you. If it did, please give me a thumbs up. Even if it didn't, give me a thumbs up. Hit the subscribe button so you don't miss that stator video, because I'm pretty sure that's going to become a popular one. Thanks for watching, and I'll see you next time.